Magandang araw! I hope everyone who is watching this video is safe, healthy, and happy. So ngayon, pag-aaralan natin a bit about nuclear chemistry. No? So we will try to have a discussion on radioactivity, the types of decay, and we will try to balance some nuclear equations. No? But first, let me introduce you some terms, no. Let us have some terminologies, no, which we shall use in our discussion. So nuclear chemistry is the branch of chemistry which deals with changes in or transformations of the atomic nucleus, no? The nuclear binding energy is the energy required to keep the protons and neutrons of a nucleus intact, and the energy that is released, no, during a nuclear fission or fusion is termed the nuclear power. Now, the nuclear binding energy is also the minimum energy that would be required to disassemble or to separate, no, the nucleus of an atom into its component parts. Now, these component parts are neutrons and protons, which are collectively called nucleons. Although we know that there are about 200 subatomic particles, and protons actually, for example, are products, no, products of quarks. No, you have the downside quarks, upside quark, no, and gluons. So when they combine, they form hadrons, and protons are just hadrons. But in our context, we shall just be zeroing on neutrons, protons, for chemical reactions, electrons. But in our particular topic, we'll be more interested with neutrons and protons, which are located in the nucleus. No? So again, the neutrons and protons are collectively called nucleons. Now, the mass of an element's nucleus as a whole is less than the total mass of its individual protons and neutrons. What does this mean? For example, the element sodium, element number 11, has an atomic number of 11, which means it has 11 protons inside the nucleus. It has a mass number of 23, meaning it has 23 minus 11, 12 neutrons. So inside the sodium nucleus are 11 protons and 12 neutrons. Recall the mass of proton, that's about 1.673 times 10 to the negative 27 kilogram. Neutron is about 1.675 times 10 to the negative 27 kilogram, whereas an electron weighs only 9.1 times 10 to the negative 31 kilogram. So Rutherford is correct, no, in his findings that the central part of the atom is massive, no, and positive in nature. Why? Because the protons and the neutrons are inside the nucleus, which is the center of the atom. That's why it's so heavy, no, in comparison to the total mass of the atom. Okay, now they found out that when you sum up the total mass of the individual protons and neutrons, in this case 11 protons and 12 neutrons, okay, the total mass is more than, no, the mass of the element's nucleus as a whole. No? So the element's nucleus as a whole is less than the total mass. Why is that so? Sabi ng mga physicists, no, the difference in mass can be attributed to the nuclear binding energy. No? So basically, the nuclear binding energy, ano yung binding energy? That's the minimum amount of energy required to disassemble, no, the nucleus into its component parts. No? So sabi nila, the nuclear binding energy is considered as a mass, and that mass becomes missing. No? Nawawala daw. Now that this missing mass is called the mass defect, no? Which is the nuclear energy. So, iba yan doon sa nuclear binding energy, no? So, nuclear power or the nuclear energy. This is also known as the mass released from the reaction as neutrons, photons, or any other trajectories. Now, In chemistry, we know that the energy and mass are different entities, no? But we are now talking about modern physics, and by virtue of the very famous equation of Einstein, here the mass defect or the nuclear energy are interchangeable. This equation tells us that energy is related to mass, and therefore both can be interchanged, no? So the mass can be um, expressed as energy and vice versa. Thus, that's the explanation. The difference in mass is now what we call the nuclear energy. So that's the missing mass. The missing mass is converted into energy. Now, so there are two types, no? There are two types of reactions. So we have fission, which is the splitting of a heavy nucleus into lighter nuclei, no? So yung fission, pinaghiwalay. Whereas fusion is the combination of nuclei to form a bigger and heavier nucleus. So yung fusion naman, pinagsama. So yung fission, pinaghiwalay. Yung fusion, pinagsama. Now, the consequence of either fission or fusion is the absorption or release, no? Either absorption rather or release of energy. Okay? Now, radioactivity is the emission of particles and electromagnetic rays from the nucleus of an unstable atom. Remember, as I mentioned earlier, there are about 200 subatomic particles. So, there are particles uh, my, uh, which are more minute than the protons, neutrons, and electrons. As I mentioned earlier, a proton rather is made up of quarks, no? Gluons. Okay, so uh, the emission of particles and electromagnetic rays from the nucleus of an unstable atom would result to radioactivity, which is a nuclear phenomenon. It happens naturally because of the nuclear instability of atoms, although it could also be induced, no, in the laboratory. Now, the substance that releases such energy, the nuclear energy, is known as radioactive substance. Now, I remember when I was a fresh graduate of BS Chemistry in 1986, there was this huge news, no, about the Chernobyl meltdown. Chernobyl is a place in the then Russia, which is Ukraine now. No? So Chernobyl is a nuclear power plant. There was a meltdown in April 1986, which caused tremendous havoc, no, not only in the place but worldwide, no. Why is radioactivity harmful, no? Radiation removes electrons from an atom, no, in the body of molecules, for example, in our body, in our human body. So since it's an ionizing energy, no, so radiation causes the bonds, no, to break, no, breaking chemical bonds and damaging tissues in the process, no. So kahit na napakaraming energy ang binibigay ng nuclear plant, no, may mga setback. So remember, yung Bataan nuclear power plant, hindi siya it was not put into operation because of fear of a meltdown, no. Okay, so kahit na maraming energy kang makukuha, yung setback, uh, sometimes the setback outweighs, no, the tremendous energy which could be harnessed from a nuclear reaction. Okay, in the Chernobyl uh, instance, uh, it was not disclosed, no. It took the Russians 3 days to disclose the incident, primarily because Sweden was alarmed, no? There was an increase in the radioactivity in their area, primarily because of the wind direction, no? Doon dinala ng hangin yung mga radioactive substance nung nagkaroon nga ng meltdown. So, nagtanong ngayon ang Sweden, meron bang nangyayari? Ganyan. So, napilitan ngayon. So, tinanong yung mga kapitbahay na bansa. O nga, parang nag-increase yung radioactive substance sa atmosphere, no? Doon lang nag-disclose ang Russia na nagkaroon ng meltdown sa Chernobyl, no? Samantalang sila ay they were able to, you know, do some damage control. They evacuated the area. They had a 30-kilometer radius, no, where everything, no, everything was removed from the area, no? And they hired liquidators, no? Ano ba yung mga liquidators na yun? So, nag-hire sila, sabi sa balita, 300,000, 600 liquidators. Sila yung na-assign to clean the area. I have read an article which said that some Russians were asked to dug a hole, no? Dug a hole under the reactor, no? By the way, the meltdown was caused by a flawed reactor, no, operated by inadequately trained operator. So, yun ang masama pag yung operator ay hindi trained, no? Parang tayo, pag ang teacher hindi trained, oh, patay tayo nung matututunan natin. Okay? So, sabi dun sa nabasa ko, syempre, I am not going to bet my life that it is true, no? Because I have not seen it. But I have read an article which says that these individuals, around 10,000 of them, were asked to dug holes under the reactor and then put some cement, no? They cemented the area to avoid, no, seepage, no? Kasi pag nag-seep down yung pagbumaba yung radioactive materials, mako-contaminate yung tubig, no, yung underground water, patay, no? You know that water pollution is very very difficult to address because it's transboundary, yung lang pwedeng sabihin niya, oh, putulin mo yung dagat sa Pilipinas yan, putulin mo yung dagat sa Sweden yan, beyond that, sa Russia na yan. Hindi naman ganun, kasi continuous yung flow ng tubig. Okay? So, yun yung hirap. So, the Chernobyl incident happened in 1986 and they made a committee, no? They put up a committee to investigate the issue. It was headed by an organic chemist, rather, Legasov, no? Legasov. So 2 years, so in 1988, 2 years yung kanyang investigation, and on the day before the disclosure of the results, so kunwari bukas i-disclose kung ano yung result ng investigation, nagpakamatay si Legasov, no? Naghang siya. Okay, bakit? Tas meron siyang mga journal na he observed political issues, no? Yun nga, kasi hindi dinisclose. Siguro hindi niya ma-attempt na maraming namatay, napahamak, dahil sinikreto yun nangyari, no? So, kaya nagpakamatay siya. Primarily, ang radioactive material which was involved was cesium-137. Okay? So, pero si yata yun na parang ginawaran si Legasov ng hero, something, may tawag sa kanila yun, na kinonsider siyang hero, okay, doon sa ginawa niya kahit nagpakamatay siya. Parang ano yun parang stand niya na bubuwis ko na lang yung buhay ko, dapat i-disclose nyo yung findings, i-disclose nyo what happened, para siguro we could learn a lesson or two from what happened, no? As long as there is full disclosure. No? So, yun. Kaya, minsan, mahirap, no? Mahirap mag-decide kasi meron ngang magandang benefit, no? Pero yung setback ay medyo mabigat din. Okay? So, yun ang kwento ng radioactivity ng panahon ko. No? So, parang ngayon, meron pa rin, radiation doon. So, mapag-aralan natin yan later on about half-life, no? Pero yung area mismo ng Chernobyl is now a sanctuary, no, of wildlife, no? May nabubuhay ng mga, sabi nga mga species na wala daw, meron na doon ngayon. Okay? Pero after the Chernobyl incident, there was an increase, no, in incidence of cancers, especially thyroid cancer, no, among children, no, children of individuals after the Chernobyl incident happened. So, yung mga babies na na-conceive after the Chernobyl incident, ang taas ng incidence ng cancer sa kanila. Okay? At saka yung mga liquidators, alam na kung ano nangyari sa kanila. Maaga silang namatay. Kasi sinabi ko na, no? So, nadadamage yung tissues ng katawan. Okay. So, these are the types of radioactivity, no? So, we have alpha decay. So, yung mga yan, ano? So, alpha particle is represented by the helium atom, no? So, we have 4 mass number and 2 atomic number. Okay? So, we have beta particle, no? So, a beta particle is represented by an electron, no? Or this Greek beta, -1. The positron, on the other hand, is like a positive electron. An electron but with a unit of positive charge. So the same as an electron, but of course it's not an electron because we know the electron to be negative. No? The proton, which is denoted, no, in some books is hydrogen 1,1. In some books it's proton 1,1. So do not be shocked, no, when you see different notations. The neutron is N10. Again, the number on top is the mass number, refers to the number of protons and neutrons. In this case, there is no proton, only neutron. And then the gamma ray. There is no change in the mass number, nor a change in the atomic number, but this causes very high energy electromagnetic radiation, no? So the gamma ray. So this is what happened in the mass number and atomic numbers when there is alpha decay, beta decay, gamma decay, positron decay, and electron capture. So you just read on this. Okay. So for example, we have this equation. No? So we have bombardment of aluminum-27 by alpha particles. So we know that alpha particles are actually helium atoms. No? So the bombardment of aluminum with alpha particles produces phosphorus 30. So the 27 and 30 are both mass number. So write the nuclear equation and identify the other particles. So this is the unknown, the one in red ink. Okay, so basically the mass number on the left side of the equation should be equal to the mass number on the right side, as well as the atomic number on the left and on the right. So I have 27 plus 4, that's 31. So we have phosphorus 30. So we need 1, no? We need 1 here. So we know that that is a neutron. Why? Because this should be 0, because 15 and 13 plus 2 are already balanced. So the missing particle is a neutron with 1 mass number and 0 atomic number. There is no proton, that's why. Another example is the plutonium-239, which can be produced by bombarding uranium-238 with alpha particles. Now, how many neutrons will be produced as a byproduct of each reaction? So we have uranium-238, 92 atomic number, no? Bombarded with alpha particles. So again, the mass number should be balanced. So we have 238 plus 4, that's 242. We have here 239. So we need 3, no? we need 3 here, so we know that we need 3 particles of neutron. So 3 times 1, that would be 3 plus 239, that's 242. Why? Why neutron? Because the atomic number on the left is equal to the atomic number on the right. So 92 plus 2, that's 94. Then that's 94. So that's how we balance uh, nuclear equations. No? Medyo madali lang siya kasi iilan lang yung titingnan mo. So as an exercise, I would like you to fill in the blanks of each of these following nuclear equations. You need to enter a form of radiation or an isotope. By an isotope, meaning an element, no? An element. Okay? If it's not a radiation, so ano yung mga radiation? Alpha, beta, positron, electron, and so on. Neutron. Okay? So that's all for now. I hope to see you next on the next video, whatever that next video is. Stay safe.